Don't do like that. Okay, here we go, voltage divider. Voltage divider. When you have series resistors across a voltage, series resistors across a voltage, then you have a voltage divider. Tell me, what if I told you, and go ahead and make this little circle, we'll call that 12 volts, we'll call this 10 ohms, and we'll call this 20 ohms. I have series resistances across a voltage. They're going to split up that 12 volts, because you know Kirchhoff's loop law says I start with 12, I'm going to lose a bunch of voltage and lose the rest of the voltage and end up with 0. That is, my voltage rise has to equal the sum of my voltage drops. So my question to you is, who's going to get the lion's share of the voltage drop, the 10 ohm or the 20 ohm? Who gets the bigger voltage drop, the 10 ohm or the 20 ohm? You ready to vote? Should we vote on it? How many people say the 10 ohm gets the bigger voltage drop? How many people say the 20 ohm? Oh, yay, good for you guys. So I'm going to explain to the class, why does the 20 ohm get the bigger voltage drop? Yes, Logan?
Because the equivalent resistance would be higher.
Okay. What do you mean? But I'm saying, why does he get more of a voltage drop than him? So you're saying because his resistance is higher? But tell me more. What else is special about this circuit? Yes, Oliver?
The current is constant.
Yeah, or the current is the same. They get the same current, right? They're getting the same current. So it makes sense if they're getting the same current, he's got the bigger resistance, he'll get the bigger voltage drop. In fact, the ratio of the voltage drops is going to be equal to the ratio of the resistances. That is, because he has twice the resistance, he's going to get twice the voltage drop, right? Which means if this is 12 volts, then this guy's going to get 2/3 of the 12 volts, and this guy's going to get 1/3 of the 12 volts, right? Because he gets twice as much voltage drop as him. If I can put this in a general statement, the voltage across R1 over the voltage across R1 is just going to equal R1 over R2, equals R1 over R2. That is, the ratio of the voltage drops is equal to the ratio of the resistances. Whoever's got the bigger resistance gets the bigger voltage drop. You see? And in fact, I'm going to show you an equation. I'm going to develop an equation. Here. You don't have to write this down. What I'm about to write, don't worry about writing it down. I just want you to see. If I've got a battery V, and I got two resistors, R1 and R2, then the voltage drop across R1 is going to equal the current, which is this voltage over R1 plus R2, times R1. Or another way to put it is R1 over R1 plus R2 times V. Whereas the voltage drop across R2 ends up being, for similar reasons, R2 over R1 plus R2 V. Okay? That's why this ended up being 2/3, because it was really 20 over 30. This guy was 1/3, it was 10 over 30. You know? And this is true not just for two resistors, it's true for any number of resistors, right? I mean, if I gave you a problem that looked like this, 1, 2, 3, 4, ... Okay? And this is V, and this is R1, R2, R3, R4, etc. Then the voltage drop across R1 would be the current, which is V over the total resistance, which, if you don't mind, I'm going to call R1 plus R2 plus R3 plus ... I'm just going to call that the total resistance. All right? It's going to be V over the total resistance times R1, or R1 over the total resistance times V. And the same as the voltage drop across R2. It's R2 over the total resistance times V, and so on. So that's a voltage divider, pure and simple. Okay? Resistors in series divide voltages proportional to the resistances. It is time for me to give you some problems. Here, give this a try. What if I gave you this? this is 5 ohms, and this is 20 ohms, and this is a, let's make it a 20-volt battery. Can you get me the voltage drop across this 20 ohm and the voltage drop across that 5 ohm? If you want to just use this formula or use this formula, be my guest. And this is the sort of thing I'm hoping you get good enough that you can just do it in your head. You know, I mean, me personally, I do this in my head. I don't write down the formula.
Oh.
I know it's going to be, you tell me, what fraction of the voltage is this guy going to get? Yeah, 4/5, 20 out of 25, right? 20 out of 25. So this guy's voltage is going to be 4/5 times 20, which is 16 volts. And this guy is going to be 1/5 times 20, which is 4 volts. How many people got 4 volts and 16 volts? Okay, several of you. Well, this is how fast I want you to be. Here, let me give you another one. Here, I'm going to give you a 24-volt battery, and I'm going to have 10 ohms, 20 ohms, 30 ohms. So this is 10 ohms, 20 ohms, and 30 ohms. I want you to get the voltage drop across each one of those resistors. And to do that, you can just do this. Just your resistance over the total resistance times the voltage.
Yes. Oh my God, yeah.
I'll give you 25 more seconds. Okay, time's up. Someone explain to me, what's the voltage drop across this 10 ohm resistor? What'd you get? Okay, how'd you get 4?
6.
Yeah, 10 out of 60, 1/6. So this is 4 volts. What's the voltage drop across that guy? Yeah, 8 volts. 2 out of 60 times 24. How about this guy? Yeah, that was easy. That's 30 out of 60, right? So it's half. So it's going to be 12 volts. You see what I mean? That's all you got to do with voltage dividers. All right, so the last thing we got to talk about is current dividers. We may run out of time, but let me just start it. Current divider. And you get a current divider when you have parallel resistors in series with a current. Parallel resistors in a series with a current. Then we call that a current divider. And in this class, I'm only going to deal with 2. I can't do multiple resistors because the equation is a little more involved, and I'm not going to do that. But here's what I'm talking about. Here's, let's say this is, let's go back to my 10 ohm and 20 ohm thing. 10 ohms, 20 ohms. And let's say this is a current I. Alrighty? That I is going to get split into 2 branches. Tell me, who gets the lion's share of the current, the 10 ohm or the 20 ohm? Yeah, the 10. Current seeks the path of least resistance. So unlike the voltages where the voltage is proportional, well, I'll complete this tomorrow. So hey, good luck you guys. Good luck on tonight's homework. I'll be here today after school. Bye-bye.